Okay, guys, I want to make sure that you have the ability to be successful in this assignment. There's a couple programs that might, or commands that might be really helpful. The first one has to do with modular arithmetic, and some of you have studied that and some of you have not. But in short, what this examines is it looks at the remainder you get when you divide a number by another. So let's say that I do like 9 divided by 2. I would expect to get a remainder of what? Of 1. Okay, so what does that mean like in terms of Mathematica though? So it says if I take 9 and I'm dividing it by 2 and I do Shift Enter, well, let's comment that out. So if I do 9 divided by 2, I'd expect a remainder of 1. Well, that's what this mod looks at. So 9 divided by 2, remainder of 1. This is going to be really helpful when I do this thing that's every 15 rolls. Because, like, let's say that I do, what I'm looking at is mod by the number of trials. And I'm dividing by 15 to see, like, am I at my 15th? Am I at my sort of 15th roll now? So what we could imagine is, maybe you're on your 39th roll. Well, that's clearly not divisible by 15. So if you divide 39 by 15, you have a remainder of 9, which means it's not the 15th. But if you do divide it by 45, which it would be every 15, so if you divide 45 by 15, we get a remainder of 0. If we do 60 divided by 15, we get a remainder of 0. If I do 63 divided by 15, oops, I got a remainder of 3. So what I want to be able to check is if this number, mod number of trials 15, if that number equals 0, then I want to record how many doubles I have. Because what I'm trying to do here is roll 2 die 500 times, creating a program that counts and prints how many total doubles I roll, counted every 15 rolls. So let's think about what that program would look like. So I'm going to do 500 trials, but I'm going to start off with 0. So this is a counter. And I want to create a variable that counts out how many doubles do I get. And I also need to create a list now that collects points. And so the first point that's going to be in there is going to be the point 0, 0, because I have, at 0 rolls, I have 0 doubles. So I want to do something 500 times, so that means I'm going to probably use a while loop, and so I'm going to say while the trials that I've done is less than 500, because I only want to do 500 trials, I need to do a trial. So I'm going to say trials plus plus, which says I'm going to add 1 to the number of trials. Okay, well, what am I doing? I'm going to create a random integer for dice number 1, and that random integer is an integer between 1 and 6 because I'm dealing with dice. And then I want to do the same thing, but now I'll call that dice number 2. So now I've rolled 2 die. And then I want to say, are these dice the same? So if they're the same, so if dice 1 is the same thing as dice 2, that means that I just rolled doubles. So I'm going to say, hey, the number of doubles needs to increase by 1. So doubles plus plus. And then what I need to do is, like, I need to make sure that I'm keeping track of every 15 rolls. Am I counting how many doubles I have? So if, and here's where we're going to use that modular arithmetic. So if mod the number of trials 15, so if I divide the number of trials by 15, and if it equals 0, which means that it's on my 15th roll, then what I want to do is I want to add to my list, which is called points, and what I want to add to it is the number of trials as my x value and the number of doubles as my y value. Cool. And let's close this. And I think that's all we need to do. So now, notice that when I press enter, because I've exited my while loop, I'm going to no longer be indented. So what I now want to do is I want to plot, so list plot, and what I want to plot is all the points. Ah, what a beautiful graph. And so some things that we would expect, down here we're going from 0 to 500 because I have 500 trials, and our y-axis, which is looking at doubles, is going from 0 to almost 100. And that but not quite 100. It's like 85-ish. And so we have roughly 85 out of 500, which is roughly 1 in 6. Close enough. So I ask you to think about what this slope means. All right, well, this program will be really helpful to you as you do challenge number 3. Thank you.